Dr. TRSDOS. I wanted to cover a subject about macros that I consider advanced macros. We've talked about conditional statements inside the macros and how you can, customize using that, conditionals. I have told you that sometimes it can be best to make an entire program a macro. And I'll explain what I mean by that. When I wrote the networking connection for TRSDOS to use the spare UART1 to connect to a server running a Python-based server program, I realized that, during initialization of the network, we may need to ping the server. If someone else, if maybe you're writing a program later, maybe you're writing a utility program, and you need to ping the server from inside your application. Saying that just reminded me of something I need to do to this program, but you're writing a utility program, and it's going to do some network functions, and you need to make sure that the network is on and running, so you want to ping it. Well, we are going to have the ping command at your TRSDOS ready prompt, but we want that inside our application. And if I ported over the entire source code for ping, that means all of its labels and variables, and some things would need changed, and the end statement would need changed, and where it begins, etc. is all going to need to be changed. So it would be a task to take the source code for ping and then put it in each application where you want to use it, simply because you may have variables, constants names that conflict with your own application. So let's since ping is not a huge program and it is something that could be used in several different applications, let's make the ping application or utility itself a macro. So here we have this is going to be the actual ping command that gets assembled, compiled, and we will save it as a command. Eventually I'll make it as a command file so it'll run under TRSDOS. I have a lot of includes up here. We've already talked about includes, and our list and our macro, turning the list on and off and the macros on and off, the listing of them to make our output listing look cleaner. So, we have some directives to the assembler here to start the code originating at 3000 org, 3000 hex, which is the standard TRSDOS application beginning space is 3000 hex. We're running this in ADL0, which means, non-ADL mode. And then I have several different libraries, macros and equates that have to be included in my program to use my library of macros that I've developed for the TRSDOS. And I'll probably be publishing those macros. I've got a little more cleaning up to do, but I'll probably share those so that other people that want to write TRSDOS applications, and you don't really want to sit and look up each command, each service supervisor call to the operating system in the manuals, and make up all the equates to call it, etc. You just want to use a macro. We'll show you here in the next application. But, a lot of the hard work has already been done for you. So we can see that we're going to org at 3000, where an application starts in TRSDOS. This is where the app begins. And then app start right here, this is where the application actually begins. And the first thing we see is the word ping. That's actually a macro. We're invoking the macro ping. And it has two inputs to this macro. Where to go to on exit. When you're finished and you want to exit, where do we go to? And what do we do if we run into an error? So here you can see that I've told it on exit. I'm telling this macro, when you're finished running and you're ready to exit, come to here on exit. And we just have a simple, here's another macro, sysexit. This is one of my macros, sysexit with a input of 0 there. It tells it was normal termination of the app, exit with no errors. If we do run into an error, on error, right here, we're going to go to the on error routine, which is right here. And we can see that it says it's another macro, error.abort with the letter A. And what this macro does is tell the system to exit the system. Is to exit this application with an abort, telling the operating system that we're aborting, something went wrong and we're aborting. And in this abort, that would terminate if we were running from a JCL or otherwise. But not only that, I can tell you that this error.abort will print the error code or the error message on the screen automatically. So what the A is saying that the error code will be in the register A. And when the ping command runs, if it runs into an error, such as it looks for the UART1, there is no UART1, something happened, or maybe it's already in use, it'll terminate. I believe that would be an error code 8, device not available. So this, when it aborts and comes to on error, it would then invoke the error.abort macro, and it would tell it register A contains the error code. And as I said, if it was an 8, I believe 8, it would display on the screen, device not available, or device not found, something like that. And here we have the end app start. And there again, we always put this, the end, we always put the transfer address, app start. So it knows when this runs, when the loader loads this program, I want you to turn control over to app start. You could have another entry point. This is app start, but you could come down here and if you wanted to say on exit, and on exit, when you would run the program, it would not begin here at app start. It wouldn't start there. The transfer address would be on exit, and it would run. That would be worthless. It would run that. It would exit the system with no error, and that'd be the end of it. Sometimes things like that can be useful when you're troubleshooting. So let's look at the ping application. This is the macro ping, and this there again is where I've told you we've developed an entire application inside the macro. So let's look at that. It's a pretty simple program. It's almost all written itself in macros. And there again, I'll probably publish these, but maybe somebody else would like to use some macros to make assembly language programming easier on your TRS-80. But my macros are mostly based on the verb, noun, format, whereas the verb comes first, then the noun, and the verb is in lowercase and the nouns are in uppercase. I figure we landed on the moon with these type of commands. It's probably good enough for a TRS-80. So here, put is the verb, put, display line, DSP line, scroll off. So there again, this $sign in the beginning tells it that this is a label used inside of a macro. And let's see, it's going to make a liar out of me. But the first time it assembles, it will be _1 scroll off with a $sign, or it's a 1 with an underscore scroll off. I forget, but each time you invoke these labels, it's going to give them an individual label inside this macro that will not interfere with your application. So if you, by chance, used a variable on the outside of your macro called scroll off, that $sign, like that, it would not interfere with the one inside the macro. If you left the $sign off like this, you're referring to a variable outside of your macro. And so it would find that in in the application that called it. So scroll off just did a quick way here of it rolls everything off the screen. What we're doing, like 25 line feeds and a carriage return. That makes sure that my cursor is at the bottom left corner of the screen. You could do a clear screen and put it at the top left. This is just something I did to scroll it off. Okay, so now we put is the verb, display line is the nouns. So we're going to display a line, ping screen. So if we look right here, ping screen, there it has the text, ping server. And this simply going to put this text here, ping server, inside the dashes and bracket with a carriage return, because there again, our macro, the verb is put, the nouns is to the display a whole line. Okay, so now here's another macro, get. Get is our verb, our action. Our noun is device control block. And I want the device control block. Here is the UART1. It again is wrote inside of a macro. Device.u1 DCB1. So what this is telling us is that the device is UART1. We want to create a device control block for that, because the screen and the keyboard in TRSDOS, there are supervisor calls to read the keyboard, write to the screen. But if you want to read and write to I/O devices, COM devices, serial ports, other I/O devices that you've generated, then you use the operating system's input-output stream or chain that's built inside the operating system. That stream or I/O stream does gets, puts, and controls, just like Unix. Get, put, and control. That's it. Everything in the whole world is based around get, put, and control. You're either getting from an I/O device, you're putting to an I/O device, or you're doing a control command to an I/O device. It's been that way since I started programming on IBM MVS. They may use different terminologies, but you are still getting and putting to devices or sending control codes to devices or receiving some control status from a device. Sometimes some machines like large mainframes, test I/O and things, that's a separate processor that's running, that's executing that command. while your mainframe can go do something else, it continues to test the I/O until maybe you started an I/O function and it's running, outputting to a printer or getting from a disk or writing to a disk. So while that peripheral is doing that, your operating system can go run someone else's program for a little while, and then keep checking back. And when your I/O is finished, the I/O device is finished, and we can give the results to your application, then the operating system is going to come back to your application and give it the results, or tell it that it just wrote your data that you asked it to do, and what do you want to do next. If you don't want to do nothing, it puts you to sleep and goes and starts running your neighbor's application. So there again, so we have get, put, and control. So for example here, I/O, put is the verb, I/O is the noun, put to the I/O. I'm telling it, it's inside parenthesis, and the way this macro is written, if this is inside parenthesis, it's an indirect pointer. So this is a pointer to a pointer. Remember, UART1 is a device control block we just created. And that's what this number 1 is out here. That tells the macro that it's UART1. And we're using the UART macro here. I did this simply because it makes it easier and more readable when I look at it later to see what I was doing here. I can see that I'm creating inside my application here a control block for an I/O device, because when I read or write to that device, I don't tell it UART1. I tell it which device control block that I want to read and write to or send control signals for. That device control block was filled in when I started my program and initialized it. I created that device control block then, and asked the operating system to fill this in. If I was to go in and look at the memory for UART1 inside here, it would have a pointer to the device control block that's located in low core memory of TRSDOS, where the actual driver is at. So this is a pointer to a pointer right here. By putting this in parentheses, that's the way it needs to be. This is a pointer to UART1. Inside this device control block, I will find a pointer to the physical device's I/O stream, and that's located in low core of in the driver area and low core of TRSDOS. Okay, so put I/O. Here I'm telling it 6 bytes. This ping string, so there again, let's look. We started with a $, we end with a $. The $sign on the end isn't relevant to this macro. What that's doing is it just reminds me that it's a string, that is text data that I'm getting here. It doesn't have to be on there. If you had left it off here and you would have left it off down here both, that would be fine. I just put it to remind myself, kind of like terminology of basic programming language. It's a string. So, but the $sign in the beginning makes sure that this label remains local, just inside the macro. The application outside of this macro knows nothing about this or any of these variables down here, or constants. So, and then again, if we run into an I/O error, if there's an error on that I/O, I'm automatically here telling it to go to ping error. Notice there's no $sign in front or behind. Where's ping error? That was an input to this macro. Remember back here on your first screen, we told it, ping, go here on exit, and go here on error. When we started, We want to know two inputs, ping exit, ping error. So anytime we run into an error, this macro, right there, we tell it to go to ping error. Okay, so let's move on. We can go, if I publish these macros, we can go further into decoding it, and it's easy to understand. So then we have the opposite. We have get as the verb, and now IO. So we're telling it the get from the IO string. Here again, the indirect pointer to the device control block, the actual for one character. Write that one character to a place called Pong Buff. Right here is Pong Buff. Define byte. Okay. We're not going to get into how this ping works. We're just covering the macros and how we can use a macro to contain an entire program. So you can't always do that, and you don't always want to do that, but there are some cases here where advanced macros really help you out. So we do some stuff here. Okay, we run some code. We can see we're doing a get again. We have another we have a little error in this. This is supposed to be lowercase cmp, but for now we'll leave it the way it is. Compare bytes, and there again, this is a macro. So we want to compare two strings. If you have two strings in memory and you need to see if they're the same, if the person typed the response that you wanted or whatever. So compare dot bytes. There again, our lower and uppercase is reversed here. That's something I have to fix. Okay, for a length of 6 characters, this buffer compared to this buffer. And if they're not equal, go to this no pong. And look, right here is no pong. No pong says they don't match. There's a return address on the stack. I needed to discard here. I'm going to display a line. No pong received. No reply from ping. And then we're going to go to ping exit. Now notice we didn't really have an error here, so that's why we didn't go to ping error, because this really wasn't an error. It just didn't respond. Maybe that's the way it should be. Maybe you have it turned off and that's what you intend for it to be. So that in itself is not an error when it doesn't respond. Everything actually worked. What is an error is if we read from the IO device don't exist, the IO device don't respond, things like that. When I say it doesn't respond, I mean that we went to get from the device and we sent it a command, and for whatever reason it's not working at all, and there was a timeout. That's different than it just didn't respond because, well, it doesn't exist. I'm sorry that it didn't respond because you have the server set to not respond. It's kind of a different situation. So it's not an error. We simply come down to our exit and we go to the ping exit. Again, input to your program, you told it ping exit, where to go to on exit. And let's remember where that is. That's back here in our other program. Ping exit, on exit. Remember, these labels here, these are the actual physical labels to where to go to. When we look inside of our macro and we start off ping exit, ping error, I can call these anything I want up here, but the order they're in is the same order that you need to have on your application that invokes it. Okay, so now we've seen how we can call a macro as if it's a subroutine. All of our labels are private inside of that subroutine. All of our data inside the macro is private to that code unless we don't want it to be, then we can, leave off the $ that precedes the label, and then your application and the macro is talking about the same. It would be the same label in both of them. So then let's look how that assembles. We already know we were orging at 3000 hex right here. Here's our, whoops. Do I have the wrong program up? It's bad when you have to debug your own programs live on the air. Okay, sorry. I had the wrong file up. I had to pull up the correct one. So here we can see at 3000 hex, the beginning of our application, our ping application. We have right there you see a ping command. This is that program we looked at the first time. This is a so there's the macro ping on exit, on error, where to go to. Here is the macro expanded out, so you can see. I know it really looks confusing, and in some ways it is. But if you're really working on a problem and you're used to using this, and you're familiar with it and you've been working with it for some time, you can easily start picking through it. We can see here, let's look at one of the macros. I don't want to spend a lot of time on this, but let's look at, I tell you what, let's look at our put display line. Remember I told you that this is going to put to the display an entire line. And a line, we mean text from the beginning until it receives a carriage return or a non-ASCII character. That's the way that TRSDOS does lines. It will output until it hits a. So here, load LD, load H&L register pair, and then we see this funny looking label there. And if we keep looking down here, we will see 1__1 10 ping to ping. Don't ask me why I called them these names, but you can see the label right here for this string. And let's look back at our ping macro, and right here in the source code you will see ping to ping. There's a line ended with a carriage return, cr.asc. That's in my equates, a carriage return in ASCII. Okay? So if we look inside here, we will find all that. It's just when this macro assembled, the assembler assigned this _110. That was because we had a $ in front of the label, remember? So that way, each label will be independently, and if outside the macro, you could use ping screen outside of the macro, and it would be referencing a completely different set of memory, because this one is really __110 ping screen. So I know it's a little confusing, but this will list out the macro. I think we will call this expanded. When the macro has been invoked and assembled, if you list all the code that was inside the macro, they call that being expanded. So how do you know how to do that? Let's go real quick over here to our assembly, our Zilog development system. I'm going to look under project settings. I get myself in trouble here when I don't pre-rehearse this, but I think I can find it pretty easily. Okay. So right here, under assembler, in project settings, under assembler, I have checked here, generate assembly listing file, a .lst file. So that right there tells us to generate an assembly, a listing that we can print or whatever we want to do with it. When we generate that, if we click this block, expand macros, then it's going to expand the macros in that listing. That's invaluable if you have to do troubleshooting. If you're only going to have one printout of your program and keep it for historical reasons and have it around forever, you need to make sure that you expanded all the macros, or otherwise you have to hand figure out how it assembled them. But let's turn this off for 1 second, and we're going to let it assemble again, and then I'm going to pull up the listing, and I just happen to know where it's going to be here. I want to check the time, 16:17. That's right now. So that means that assembly I just started, it finished, and this listing is the most up-to-date one, because I started the assembly and we didn't watch it run completely. So we wanted to make sure it was finished before I pulled this listing up. So now, since I turned the expand off, if we look at our macros, it made a complete liar out of me. They're still expanded inside here, aren't they? Okay, sorry, I had to locate the correct spot in the code here. So now, when we turn that expand off, expanding macros, here's the code as assembled. Here's the macros, and you see no code. You see no addresses except for the transfer address or other. So the assembly looks a lot cleaner. It's easier to read. But if you were troubleshooting and you needed to know, when I did this, put display line, exactly how did that macro assemble, then you need to use, over here under setting, project settings, you need to turn on and off under assembler, expand macros, turn that on and off so that you will be able to, if you've already worked with this program and it's working and everything is happy, and you just need to print it sometimes because you're reading it and thinking about improvements or changes, you don't really need to see that individual code in there. But here's an example with it running on, expanding on, and you can see when I do the put display line, this is showing you how that macro assembled. It's loading the H&L register pair, doing a supervisor call to the SVC display, load register A with that. This is a macro here. It's a macro inside of a macro. Supervisor call. And I'm telling it to call the supervisor and hand it SVC underscore DSPLY. This was defined in an equate file. So we can even see what it. So 3 echo is load register A with a binary value that follows right after the opcode of 3 echo. The byte that follows 3 echo is alpha, which is display byte. See if I can find it real quick. If we come over to our programming manual and let's see, let's look under display. display line. Remember, display line was loading a alpha, the letter hexadecimal A, which is 10. These here, SVC 10, this is in decimal. So 10 is hexadecimal and alpha A, 0 alpha. So the display line, this is the TRSDOS programmer's manual. So we needed to load register A with a 10 decimal or a 0 alpha hex. The assembler shows the values in hex. So 3 echo, load register A with a numeric value that follows the opcode. Right there is the 0 alpha. So that's because SVC underscore DSPLY, there's an equate file that already told it that it's a 10 or a 0 alpha hex. Restart 28, that's another macro that's going to do a restart. RST 28. All TRSDOS supervisor calls goes through the RST 28, that's 28 hex, to call supervisor calls. So there we have it. We can see the reason or the need for writing perhaps a macro that acts like a program. Now, there again, this ping, let's find the macro for ping right here. So if I wrote another program, and let's say I was just on a utility, was going to do something with the server, but first I need to check and see if it's on. What I could do is invoke the ping macro, tell it where I want it to go on exit, tell it where I want it to go if we run into an error. And so when I exit, if you exited, you can consider that it worked. So maybe I have a message then that would say, okay, server pinged, everything's fine, what do you want me to do next? And continue on with my application. This allows me to write one set of source code, use it in multiple different programs when I want. Everything inside of this macro is private, except for these 2 vectors that I give it on input. These are not private to the macro. These go somewhere outside the macro, which is what we wanted to do. Okay, so I hope maybe this has helped some. Didn't mean to go 40 minutes, but if you're interested in some of my macros, I could probably email them directly to you if you wanted to play with these. You could always contact me. Otherwise, one day they will be published. Again, I thank you for watching, and get out there and write some TRSDOS applications.